This look through the prism may adapt seasonally. The Alaskan wood frog has developed the ability to freeze over 60% of its body as a way to survive the harshness of winter. To take a look at how this works and why this works, and the range of options animals use to cope in frozen climates, we are being joined by Don Larson. He's a Ph.D. student at Fairbanks. Welcome, Don.
Thanks for having me.
So, when we were talking about this in the newsroom, there were people who had heard that Alaskan frogs sometimes were found to be frozen solid in rivers and other places, and then would thaw out for the spring and be relatively well. But this is slightly different. We're talking about frogs that are partially frozen and still function.
Oh, right. Well, the stories you've heard, there's actually been quite a few stories where old miners back in the day, the gold rush days, would find wood frogs near campsites, possibly, and when they were making their campfires, and the frogs would thaw out as the fire was warming up the frogs. This is actually very similar to that. So we're finding wood frogs are finding little places to hibernate near ponds where they breed, digging small little shallow holes, only a few inches to or a few centimeters deep at most, and waiting for ice to form around them, and spending their whole winter in this frozen state. So when we say about 60 to 70% of their body water is frozen, the other percent that's not frozen is the water really inside their cells. So it's everything around their cells that's freezing.
But wouldn't that make them exceptionally vulnerable to different kinds of predators? I mean, if most of your body is frozen, it's very hard to get away if you're out in the open in a little ditch.
Well, so they make sure to hibernate under leaves, so they're pretty well covered. And I can tell you from my own experience that these guys are very, very hard to find. So they're not only under the leaves, but they're also under quite a lot of snow. But if you actually go out and look for these frogs, and I've done this before, you can rake around ponds looking for them. And I've spent 2 weeks, 7 hours a day raking, and I was able to find 2 frogs in a place where I know there's 10 times that many.
So in reality, we're talking about a frog that's not freezing 60%. So it's not freezing its legs and maybe one arm. It's just reducing its overall temperature to slow down its metabolism.
So its legs are frozen, its arms are frozen, all the water in it is frozen except for in the cells. So the thing about ice formation and freezing is freezing's only lethal once you have ice inside your cells. So cells can survive with a little bit of ice around them. They just can't survive with ice inside them.
How effective is this? Is this something where the frog is very vulnerable? Because I imagine a few degrees either way and it might reach a tipping point.
No, this frog, in Alaska, they're very hardy. So for our frogs, they were getting down to negative 20 Celsius, so right around 0 to negative 4 Fahrenheit. They're getting pretty cold. And we have some evidence that they might be able to go even lower than that. But the thing that really tells us that they're very hardy and able to survive these conditions very well is we didn't see any wood frogs die. So we looked at wood frogs over 2 different years. We had looked at almost 20 frogs total, and we didn't see a single frog die that following spring. So they're not very susceptible to really low temperatures. Even in this frozen state, they're doing really, really well.
I guess I'm returning to the same question. It still seems to me that maybe some die, but the ones who might have died are the ones who got caught by predators. I would imagine that a certain part of the population, different animals probably have learned to adapt to ferret out those camouflaged leaf-hidden frogs.
There's not too many predators, so the area we're talking about, the subnivean space underneath the snow where these frogs are, there's not really many animals active in that area. There's shrews and voles, but foxes aren't really digging through the snow looking for wood frogs. They're instead looking for rabbits and hares and of that nature. So we don't have any evidence at this point to say that shrews or voles are actively seeking out wood frogs and noshing on them during this frozen period.
And is this a relatively unique quality? Are there other animals that use the same mechanism, use the same trick?
So it's very unique for vertebrates. But there's insects that are capable of surviving really cold temperatures in a frozen state. But insects also do something called supercooling, where they prevent any ice from forming. And we actually have an insect up here, a beetle larvae, that gets so cold it actually vitrifies, so it turns into a glass-like state. But for vertebrates, there's another species of amphibian over in Siberia, a salamander, that also seems to be very freeze-tolerant. Although we have yet to see the same length of period surviving freezing, so they've only shown this salamander can survive a few months frozen, and they don't really show the survival that we do. So they've taken these frogs to lower temperatures, these salamanders to lower temperatures, to about negative 35 Celsius. But they haven't shown the same survival that our wood frogs have.
So this is another example of you are what you eat. These frogs eat these insects that seem also to be able to withstand cold temperatures. And
not necessarily, no. So these wood frogs have special adaptations where they're able to make something called a cryoprotectant. It's these low molecular weight molecules. In this case, it's glucose. And so their freeze tolerance has more to do with being able to pack lots and lots of sugar into their cells. So freezing isn't lethal because ice crushes our cells. When we get frostbite, it's not because there's ice stabbing our cells. They're actually drying out. If you've ever seen somebody with really severe frostbite, their skin looks almost mummified and desiccated and dried out. And so by packing their cells with this glucose, with this sugar, wood frogs are able to prevent ice formation around their cells from drying out their cells.
Well, that's kind of interesting. When I've interviewed people who are conducting research in Antarctica, one of the things they told me is they had to begin developing a diet eating 4,000 calories a day. They would eat huge Hershey bars, whole sticks of butter. And I'm guessing in a way that may be similar in the sense of generating all these calories and especially high sugar calories.
Well, in that case, they're trying to generate lots of calories to keep warm. In this case, the wood frog's actually trying to produce lots of sugar, not for its caloric properties. So it's not using the sugar for energy. It could be any other kind of low-weight, tiny molecule to lower the freezing point. It's more using it like we use salt to sand a road, to help things melt and prevent ice from forming within the cell, and then also to prevent this kind of drying out.
So the sugars aren't being slowly burned as food, as energy during the hibernation periods?
No, not really. So since these wood frogs are at such cold temperatures, there's very little metabolic activity. I mean, as organs, there's no real organ function to speak of. Since ice is surrounding all these cells, we don't have brain function, we don't have liver function, we don't have kidneys functioning, there's no heart beating. So there's not a lot of things that are metabolically costly going on during these 7 months.
Now, beyond the scientific curiosity of how these frogs achieve this, are there any other practical implications or any other research we might be moving towards to take advantage of this adaptation that these wood frogs have learned?
Oh yeah, there's some really great futures for this kind of thing. So, I mean, even if you just look in your freezer, if you keep a steak in your freezer for too long, what happens to it? Well, it gets really nasty freezer burn after only a few months for me, or same with peas. Well, these wood frogs are surviving those same conditions without freezer burn. So imagine if we can figure out how to keep food from going bad so quickly. Or, even better, if we can keep organs, whole organs that we need for transplants, in a freezer for 7 months, and we can get it to who needs it without having to worry about immediately transplanting it to the person that needs it, to a person nearby.
Now, in the first case, I would imagine that would involve genetically modified materials. In the second situation, I don't know that you'd want to genetically modify the kidney or the heart or the lung that you're wanting for transport. So how might you go about creating the situation where the heart can survive it without changing the heart?
Well, I don't think we're at the point of splicing frog genes into anything so much as at this point of understanding what's happening within these cells, within this very large organism where the cells aren't being harmed by freezing. I think that's what we're looking at first before we really are able to grasp everything that's going on at the genetic level. We're still trying to understand a lot of the physiology involved.
Yeah.
So to answer your question, I don't even know how we would begin to start freezing even small organs for people before we can get to the point of that kind of transplant. But it'd be one of the key futures for this is what can we do to help people out with transplants would be a big one.
And forgive me, because one of the things we do occasionally delve into here on the Prism is the fact that we live in the land of science fiction, and so many of the things that we thought were impossible are suddenly becoming realities and then becoming dwarfed relatively quickly. And so when you were talking about these adaptations with frogs and the possible application, I thought of what you were talking about. I was thinking of cryogenics. I was thinking of all sorts of uses, and mind you, some of them may still be in the world of speculation.
Oh yeah, well that's definitely a future for this too is cryogenics or hibernation and sleep. So one of the other areas the lab I work with studies is bear hibernation, and there's definitely a future in that for space travel. But for me, I would see it as even a further point of not only cryogenics for freezing maybe sick people, but also being able to travel in space. I mean, imagine if you could freeze somebody for 7 months, the costs of oxygen and heating the spacecraft and feeding those people are now down to next to nothing. Of course, there's quite a few hurdles before you even get anywhere near freezing something warm-blooded, but still the idea could be quite intriguing for cost savings in future spaceflight.
And as we know, in terms of space flight, and even in terms of standard flight, weight is an essential thing. Anything you can do to reduce the amount of weight, the payload that you have to, move, would be a huge advantage. But let's get back to bears and frogs. When you're looking at these different animals and the different techniques that they use to survive these winters, do you see large parallels?
For bears and frogs, there's parallels in that they're trying to limit their energy expenditure in winter. But they really diverge in that bears are reacting to a lack of food, while frogs are more reacting to low temperatures that they can't keep themselves warm during. So for frogs, it's more a reaction to the coping with the low temperatures. With bears, I'd say it's more coping to the low food availability.
And I guess the final question, unless you tell me something that we ought to have covered, which I haven't, is I imagine another species which has to deal with very cold temperatures very often are fish. Do you see some of these processes in how fish adapt to swimming and living in very cold temperatures sometimes?
So there are, again, very similar, since fish are, also ectotherms, they're reacting to temperatures much like the wood frogs are. The difference is there's no freeze-tolerant fish that we know of. There's some stories out there of blackfish in the Arctic being able to survive freezing, but we've never been able to mimic that in lab conditions. There are other fish in the Antarctic that have antifreeze proteins that allow these fish to survive in icy conditions and avoid freezing. But I would say that there's probably more in common with other hibernators like the bear than there are with active fish, since fish in the Arctic are still swimming around underneath that thick layer of ice.
Well, looking at the way different organisms survive the cold in Alaska. I'm Andrew Hiller for Radio VR in Washington, and I've been joined by Don Larson. He's a Ph.D. student, a doctoral student at Fairbanks. Thank you so much.
Thank you, Andrew.